tardes a todos. Bienvenido. Me llamo Sebastián Durán. Soy el desarrollador principal de Scala.js. Y como puede oírlo, no hablo muy bien español, así que voy a cambiar por inglés por la presentación. So that's it. So about going from ECMAScript 5 to ECMAScript 6, and then further to Scala.js, which is Scala compiled to the JavaScript platform. You will often hear me talking about the JavaScript platform more than the JavaScript language, because I think that the JavaScript platform as such has by now gone further than JavaScript as a language per se. Given that there are literally hundreds of programming languages that compile to JavaScript, so it's possibly more than languages compiling to x86 by now, because most of the other languages compile to some sort of virtual machine. So I think JavaScript is now more important than machine language, basically. So let's first start with a few buzzwords. So examples from JavaScript, from Scala, are snippets of code that don't really behave the way you would expect at first glance. So I saw there were many JavaScript people here. So do you recognize this one, and do you know what it evaluates to? Anyone? You would expect an array of 4 tens, right? Through it's really not that. It's this. So it is the number 10, then nan, then the number 2, and then the number 3. So anyone wants to try and give an explanation for this one? It's perfectly normal. It's not a bug. It's specified that way. So if you desugar the map, you receive this. So you receive calling parsings 4 times. But not only with the string 10, but also with the index in the array. So you get parsing the number 0 and the number 1. And guess what? This second position of the function parameter is the base in which the string is to be interpreted. So it defaults to 10. So 0 being falsy, it defaults to 10. And then you interpret the string 10 as in base 10, and that gives you the number 10. But then interpreting in base 1 doesn't mean anything, so that's no number. That's perfectly okay. Then base 2 and base 3 obviously give you 2 and 3. So to fix it, you want to explicitly introduce an additional lambda, which I'm introducing you to arrow functions in ECMAScript 6. In case you've never seen one, I doubt so. And then the second parameter is lost because the second parameter of the lambda is not used, and you only call parsing with one parameter, and then everything works fine, and you receive 4 tens. So that's one example with JavaScript. Let's also make fun of Scala, right? So there are quite a few less people about Scala. Anyone wants to try about this one? What would that give you? I guess you would expect a set with one element which is null, right? But this gives false. So that's another tricky one. The thing is, if you just remove the pair of parentheses there, then you receive what you would expect. So if you just say toSet and not put the empty parentheses, you receive a set with an only element which is null, because when you create a new array, the array is filled with nulls. So when you convert that array of nulls to a set, well, the set only contains one version of null, which is null, which is fine. But then if you apply the parentheses, then Scala desugars that as calling the apply methods of the resulting set. And because the apply method expects one argument and you didn't provide one, it will helpfully insert the argument unit, which is also spelled as an empty pair of parentheses. Unit is sort of the equivalent of undefined in Scala, in the sense that this is what methods that don't return anything return. So if you don't have an explicit result value in a Scala method, if it's a void method, it's actually returning units, and the empty parentheses is the only instance of unit. So we have JavaScript, we have Scala, and both have weird corner cases at some points. So imagine what we can do as weird cases if we mix the two together. Anyone wants to try and guess what this one gives? So now we're not creating a Scala array with 3 elements. We're creating a JavaScript array, but from Scala.js code, and then turn that into a set. And then you will notice the same trick with the empty parentheses. Well, this one gives true. Oh yeah, maybe I should first, I forgot to explain why apply as such returns false, which is a crucial part of the thing. So the thing is, the apply method on a set is defined as is basically contains. So it tests whether the set contains the value unit. But we've seen that the set contains only the value no. So it's quite normal for apply to return false. If you ask, does the set contain unit? No, it doesn't. So I'm answering false. So now we have this one which returns true. So, well, if we again remove the empty parentheses, we receive a set with the only value which is undefined, which we would expect, right? Because as all of you are most of you are JavaScript developers, so you know that when I create an empty array with a definite length, the elements are not truly there yet, but if you still try to fetch them, you receive undefined, right? So it's quite normal that you receive a set with the value undefined in there. So then the same thing applies with the empty parentheses, and then the question is, does unity fall undefined then? And the answer is true. So yeah, it doesn't really display really well on this screen. It's a pair of equals there in the middle. For some reason, you may not see it somehow. Anyway, so if I ask, does unity equal undefined? It says yes, because that's what it is. So in Scala.js, unit and undefined, they're strictly the same thing, because if you think about it, they're basically the same thing, right? In both cases, that's the value that you receive if you call a method that doesn't return anything. So it completely makes sense to equate them. And that's pretty critical to some of the parts of interoperability with Scala.js and JavaScript. But it's a bit weird at first thought. Okay, that's it for the funny snippets of code. And now let's move to the actual topic, which is we're going to go through a number of language constructs in JavaScript, ES5 to be precise, and how they have evolved in ES6, and then sort of how we can think they evolve further in. Of course, that's not how history worked, but we'll see that they're not really very different, and that you can really see it as a continuity of some sort. So the let transfer is the JavaScript way, is the ES6 way, and the var vals is the Scala way. So in ES5, if you recall, because of course you have all abandoned ES5 like 2 weeks ago, because ES6 has been standardized, right? So now, of course, all browsers support it. So of course, you wouldn't write ES5 by hand anymore. No, of course, in reality, you use Babel, right? But, oh, you still use JavaScript? Okay, that's fine. For those of you who are still familiar with ES5, this is how it goes. So if you have a var, and then you have an inner block, and you redefine another var with the same name, they're actually the same. So if you increase x, well, both x's are the same x, so eventually the last console log also prints 3. There's many JavaScript people argue, but this is how it's supposed to work, right? You only have one variable with one name and one function, and that's fine. And yeah, it's sort of fine, except that, come on, everyone else does it differently. So it still is confusing for many people coming to JavaScript. And well, in ES6, they changed it. So now they have introduced the let construct, which is basically the same as var, except that it has block level scoping. So now the let x equals 2 inside the braces is not the same as the let x equals 1, which is outside. And that means that the last console log x still sees the one that was defined in the beginning, and so it displays 1. Well, guess what? In Scala.js, it basically works the same as in ES6. So in Scala.js, you don't have such a thing as a var of JavaScript, in the sense that you don't have non-block scoping. You only have block scoping. And if I declare a var, which is the equivalent of let in ES6, so it's a variable with block scoping, the last statement will print 1. So there's another thing about ES6 is that it also has consts. Const is like a let, but it won't let you reassign the constant a second time. So you have to initialize it where you declare it, and then if later you try to reassign it for some reason, you get a syntax error. Syntax errors are great because a syntax error is basically a compilation failure. So as soon as you try to start your script, you immediately get an error. So it doesn't matter whether you have tests that reach this point, because as soon as you try to start anything, it immediately fails. So this is like a compiler error for Scala people. So a syntax error is great. And having consts all over the place is a good thing if you want to try to write in a functional style, which basically means keeping things immutable as much as possible. So in Scala.js, you have, of course, the same thing. And in Scala.js, it's actually typically the default. You would typically use val instead of var. It's basically the same thing as a constant in ES6, in the sense that if you try to reassign it somewhere, it's a compile error. So the code won't even compile, which is basically the same thing as a syntax error. There's another tricky thing about lets and consts in ES6 that are different from vars. If you have a var in ES5 or in ES6, as long as it's a var, it exists for the entire time of the function which it was declared, right? So, and before it is assigned, it will default to undefined, obviously. But with consts and lets, I have an example here with const, but it works the same with lets. If you try to read the const or the let variable before you actually initialized it in the control flow of your program, you will receive a runtime reference error saying, I cannot access the declaration of X because it hasn't been initialized yet. So this is much better than receiving undefined, because typically this is a bug in your code. So it's much better to receive a pretty immediate error, but it's still a runtime error. So you must at least enter the var method function to get the error. So this is known for the specification guys as the temporal dead zone, TDZ, because it's temporarily dead. There is a zone in the timeline of the variable in which it's dead, and if you try to read from it, it will throw an error. So in Scala.js, you have sort of the equivalent, but it's a static dead zone, in the sense that it's lexically defined. So if you try even to write this code, which is basically the equivalent within Scala.js, you receive a compile error again. So you cannot even try to access X before it was declared lexically. So if you want to fix this error here, you have to move the definition of var below the val X declaration. And that means, again, that the first call to var will fail to compile for the same reason, because it's lexically before the declaration of the definition of var. So this improves a little bit on the temporal dead zone in the sense that you get a compile error instead of a runtime error. So in that sense, it's sort of an evolution of the latent const principle, but pushing further to having static combination error rather than reference errors at runtime. So that was easy. Now let's move into classes. So you've probably heard that ES6 has gotten classes. Who is happy about it? Wow, that's a JavaScript crowd. So have you ever heard of prototypes? Yes. What do you use them for? To make classes, right? You just do it so you just do so in a very imperative way and in a very verbose way. Who has ever used prototypes for something else than declaring classes? Who has ever seen another developer use prototypes for something else than declaring classes? Yeah, that's what I thought. So I've never used prototypes for something else than declaring classes, obviously. So the thing is, prototypes are effectively used by JavaScript developers to declare classes. It's just that it takes a huge amount of code to do so. So why not instead provide syntax checker to do the same thing? And that's basically what ECMAScript 6 classes are. They're just syntax checker on top of prototypes. And they codify in the language what has become the de facto use of prototypes in the language. So it is a good thing for JavaScript developers. You have to type less to do the same thing, right? This is very good. You should be rejoicing, right? So look, in ECMAScript 5, you had to write all of this to declare a class. First, a function, which is a constructor, initializing the fields, and then manually assigning all the functions to your to properties of the prototype. For example, to declare a method distance that takes another point and computes the distance. It gets worse if you need inheritance at some point, because then you have to reinitialize the prototype property itself with an instance of the inherited prototype, but taking care not to call the actual constructor function because you don't want it to be executed, because you don't want to create the fields on your prototype, to have the inherited prototype in your prototype chain. And then that screws up the constructor property of the prototype. So you have to reassign the constructor property of the prototype to, again, refer to the actual constructor of that the class. And then only can you start adding methods to this prototype. So this is a huge amount of boilerplate to basically write this, which is the ECMAScript 6 way of doing it. You declare a class, rectangle, declare the extends shape, and then you can declare the constructor. So ECMAScript 6 actually requires you to call the super constructor in a constructor before you use this. So I have to call the super constructor even though it doesn't have any parameter, and we can suppose it doesn't do anything. But it's required. And then also method declarations are also much more declarative. So really expose the intents that you are trying to expose in a declarative way. And this is simply more readable. It does the same thing, but it's more readable. So Scala.js also has classes. They're a little bit shorter even, because Scala basically conflates both the constructor and the definition of the class header. So at the same time, by declaring val width and val height here, we both declare the parameters of the constructor and declare how they're supposed to be assigned to fields. So it's the same thing. And the rationale behind it in Scala is to say that width and height are essentially parameters of the instance of rectangle, which sort of looks like the parameters of the constructor function of the JavaScript, the ECMAScript 5 kind of way of doing it, if you want. Short thing on syntax. So Scala.js is actually a bit more verbose on declaring methods. You have to use a def keyword, and it's not strictly required, but it is good practice to declare explicitly the result type of your public methods. So in general, Scala is able to infer a great many number of types. but it does not infer the types of parameters. So these types are required. This one is not strictly required. It is good practice to explicitly write the result type of your public methods, because otherwise short disturbances in the way you write the code could change the result type of your public interface, and that's weird. Usually we do it. But basically, Scala.js here combines both the ES5 way of declaring parameters to the instance as parameters to the constructor function, which represent the class, and at the same time the terseness of ECMAScript 6 way of declaring things. So in fact, most Scala developers would write the previous example like this. So removing the this dot, because being a lexically scoped language, it's the compiler knows that this width here is actually the same as this one, so it must be the this dot width. And also, we typically don't write the braces here if the body of the method is a one-liner. You can also see that the results of the method is implicit. So in ECMAScript 6, you need the return keyword here. In Scala.js, usually you don't write it. You can, but you will be frowned upon by other Scala developers, because that's not good style. Okay. Another feature which is I think JavaScript developers like much better than classes in ECMAScript 6. It's arrow functions. So who likes arrow functions? Ah, yeah, I thought so. So in ECMAScript 5, if you want to declare a lambda, so an anonymous function, you use the function keyword, the parameters, braces, and then return whatever you want to return. And for example, you would use that if you want to map an array of numbers which are evens to an array of numbers which are odd. A more extensive example uses a method in a class, and then you want to use the function, an anonymous function, as the body for an on-click handler. And there you want to call another method of the same class, and then you have to declare self before, because this here would not have the right binding. So arrow functions try to solve both the verbosity problem and the lexical, the dynamic this problem. So in ECMAScript 6, the first example becomes very terse. You just use x arrow x plus 1 and see how it's kind of Scala-ish in the sense that the result of that function is implicit for an arrow function. So if you don't have a full block of code for an arrow function, it implicitly means I'm returning x plus 1 here. And in a class, you also have an arrow function here, and here I can just use this, because in an arrow function, this is lexically bound to the immediately enclosed function, which here would be the method setup, and so it's the this on which the method setup was called. So in Scala.js, it looks very much the same. So the first example is basically the same thing. I also have x arrow x plus 1, and this is exactly the same thing. It's lambda, it's an anonymous function taking parameter x. In this case, the type of the parameter is inferred. You don't have to write it. Usually, the parameters of anonymous functions can be inferred by the Scala compiler, because it's pretty smart about them. And again, the result body is implicit, so you don't have to write return. And again, for the on-click event, here, for some technical reasons, it cannot infer the type here. It could if this was, it might come true, it will come true in Scala 2.12, actually. But in Scala 2.11, unless you use the experimental flag, which you should not use because it's experimental, it won't be able to infer this, so you have to write it. But otherwise, it looks pretty much the same. So you also have an arrow function, you have an implicit return, and you can use this, and it's lexically bound to the enclosing def method. So arrow functions in Scala.js, you only have defs, which are basically the same as function in ECMAScript 5, and arrow functions, which are the same as arrow functions in ECMAScript 6. Everyone following into here? No complaints? If you want to raise any kind of question or concern, ask away. So again, here from this side to this slide, I'm just removing the this dot because typically you don't need it in Scala.js, so typically you don't write it, but it's the same. Another ECMAScript 6 feature that basically everyone likes as soon as they have discovered it is default parameters and variable methods. So in ECMAScript 5, you typically have to mess with the arguments parameter, who has already used the arguments parameter sometimes to implement some method. Oh, not so many as I thought. Where you're already falling asleep. No, very nice. So if you want to have default parameters, you basically have to test explicitly, is it undefined? Then I will replace it with my default value, which is 42, and otherwise use the value, and then I can use it. And if you want to define a max method, which takes an arbitrary number of parameters, you have to iterate over the arguments. Oh, forgot a space here. Sorry for the JavaScript style. So you basically have to use the arguments magic variable. And so arguments is a bit weird because it interacts with the actual declared parameters of the function. And it's also very fragile in terms of optimizations by the VMs. So if you do anything but selecting length or an indexed field of arguments, then the VM says, help me, I don't know what to do, and it de-optimizes entirely the function. So we recognized that a lot of JavaScript developers are using this pattern of default parameters and then variable methods, and introduced default parameters and rest parameters. So for the default case, just use equals 42, and then for a variadic number of parameters, you use this triple dot syntax, which is awesome. It's better than the Scala syntax, by the way. I wish Scala had a nice syntax like this. So, and then rest is a proper array. So you can use it just like any other array, and you're sure that it won't behave weirdly with respect to other stuff. And the JavaScript VM is able to optimize it properly. At least they will be able to optimize them properly. Not yet. Also, one tiny detail is that here I'm using index starting from 0, and here I was starting index from 1, because arguments always counts the first argument as well, so you have to account for it. But the rest array only uses the rest parameters, not the ones that were declared. It's typically more readable. So in Scala.js, you have pretty the same thing, just with uglier syntax. So in the default parameters is just the same. So you just have equals 42 and then it defaults to 42. You have to declare the type because they're parameters. And for rest parameters, you have this star notation, which is not as nice as the triple dots, but it's kind of okay. And then you can basically do the same. So you can use it as an array. So technically it's a sequence, it's a seq in Scala terms, but it's basically an enhanced array. It has many more methods than an array. So I want to talk a little bit about how it looks like in Scala.js when you actually talk to a JavaScript library, because I've seen now at all the features that look alike and that are needed so that we can talk to JavaScript in the same way in Scala.js. So if you have ever used any other compiled to JavaScript language that is not a syntactic or type-ish extension of JavaScript itself, so not something like JavaScript or TypeScript, but something like Git or ClojureScript, well, ClojureScript is actually pretty good at it. But all the other ones, Fakes or such. Well, if you want to talk to JavaScript, either you're lucky and the framework or someone else has already written bridges so that you can sort of talk to the JavaScript library you want to use, or you have to write JavaScript fish code inside strings or comments inside the host code, which is completely ugly, and I really hate it. And from maybe not from day one, but certainly from week 3 of developing Scala.js, I realized, oh god, I have to do it right. I cannot do it like all the other ones because it's so ugly. So in Scala.js, I think we did it right, but you will be able to tell me. So here is how it looks to talk to a JavaScript library in Scala.js. So I'm in a Scala.js piece of code, and I'm creating a XML HTTP request instance. So typically we use something like a jQuery, and here I'm using the underlying one just because it highlights more features, but you can do it with jQuery as well. And then I call methods on it, and I pass it strings, literals, and then I assign to a field, and I give it a lambda, which is a Scala lambda in the first place, and I'm reading the status field, and I'm reading the text content field, etc. So it's basically like it's the same thing. It's hard to see at first glance which is a JavaScript call and which is a Scala call. In this instance, most of it is actually JavaScript calls, but in Scala.js. So you can directly embed your JavaScript intent in the Scala.js syntax, which, by the way, is very close to JavaScript syntax. So it really feels the same. One thing to note here is this double equals here is a equals. So it's not quite the equivalent. It's certainly not at all the double equals of JavaScript. In this case, it's more like triple equals in JavaScript because I'm comparing primitive numbers. In general, it's more like the equals method of Java, but in this case, it's the triple equals. So Scala.js never exposes the double equals of JavaScript. You just cannot use it. You have to use the triple equals. Anyway, JS linters typically don't let you use double equals either. So how do we instruct the Scala type system that we are able to write this? We give types to JavaScript libraries. So this is not like a bridge in the sense that there is no code in there. No runtime code. It's just types so that the Scala compiler can understand from a type what the previous code means. But the resulting calls are direct calls to JavaScript from the caller. And we can see a few things here. So the first thing to note is that this class here extends the JS interface of traits, which is here, which basically means this is a JavaScript type. So don't emit actual code for this for the methods of this class because it's actually written in JavaScript in the first place. But now you have told the Scala type system how it can type check calls to these methods, and also how your editor can autocomplete your calls to your methods and such. So if you have read a little bit or used TypeScript, this is very similar to how TypeScript does it. And it was partly inspired by how TypeScript does it. It goes a little bit further than TypeScript in some respects, leveraging the Scala type system, and in some respects, TypeScript is a little bit better. For example, for now, Scala doesn't have union types yet, so sometimes a little bit awkward. But also we have the distinction between a def, which is a read-only field, and a var, which is a read-write field, which TypeScript doesn't have. We also have val, which is a read-only field that will never change, but I don't have an example here. But otherwise, it looks pretty much the same. Any questions here? Might be a bit disconcerting to JavaScript people at this point. Yeah.
You also use overloading method with Scala.js?
Yes. So you would declare them as overload methods in Scala.js. The system of Scala will decide which overload to select as a symbol, as a declaration, and then eventually it compiles to the same code in JavaScript. So you get the type system point of view of overloads, and eventually it translates to what JavaScript believes to be overloads, which is runtime dispatch. But that's how it expects it, so it's the right thing to do.
But when you are trying to use code compiled from Scala.js from JavaScript, this overloading method will have a different name, or do you make this?
Okay, I misunderstood the first question. So I understood the question as, can I encode in such classes methods that are runtime dispatched in JavaScript for consumption by Scala.js? But
I mean, you're trying to find a solution for this, or
so
I mean,
there were
the example when you want to use JavaScript from Scala.js, and so it's possible, or if it is to use the code compiled from Scala.js from JavaScript, or not, it's a whole.
These are two very different problems actually, and it's also a different problem from encoding overloading from a Scala point of view. So in this presentation, I don't really have any extensive examples of calling Scala code or Scala.js code from JavaScript. What you have to do is basically add an annotation at JS export on the methods that you want to call from JavaScript. I can show you an example afterwards if we have time. Here, this example is more calling JavaScript libraries from Scala.js code. And in there, overloading is just, you would define several overload conditions, and JavaScript would understand that as overloading. For example, the jQuery function, it takes like 6 or 7 different types of parameters, and depending on which type it is, it will do different things. For example, if it's a string, it will resolve it as selecting from a CSS descriptor. But if it's a DOM element, it will just create a jQuery with one element, which is a DOM element. And you can declare several methods for that in Scala.js, so that the Scala system is happy, but eventually it compiles to the same call in JavaScript, so that JavaScript is happy in the end. And then the third thing is encoding Scala.js classes, which are truly Scala code, that do have overloading in it, which is supposed to be statically resolved. For these, we rename all the methods. So, and that does not apply only to overloaded methods. In general, Scala.js renames all the Scala methods. It will systematically encode the full signature in the name in the compiled code, so that methods that are overloaded in Scala end up having different names in the compiled JavaScript. But this is actually an implementation detail. You don't have to see that. Because if you at JS export something, it will be exported on its original name. And if need be, with runtime resolution of overloading. So, yeah. That was a short question with a long answer. Any other questions? Okay. So, okay. So, another thing that ECMAScript 6 brings is template strings, which is known in Scala as string interpolation. So, in ECMAScript 5, if you want to construct a string which consists of portions of strings and then inside variables from the encoding scope, it looks like this. You have a lot of string concatenation. And it is pretty unreadable. So A lot of languages by now have some sort of way of embedding variables from the enclosing scope inside strings, and that will be replaced by their toString, or you call it the toString method or equivalent. So ECMAScript 6 has this under the name of template strings. A template string begins by a backquote, which is hard to type on some keyboards, but not on the Belgian one, so I'm happy. And then you can use dollar, phrase, and then the name of a variable. It will embed the value of that variable inside the name. And you can also put complete expressions. So it's complete JavaScript expressions in there, so you can put complete things here. In Scala.js, you have the same thing. Well, basically, it's another thing. This is much weirder. This is user-defined template strings. So you can put an expression which resolves to a function in front of the template string, and that will call that function with complicated parameters. I refer to the specification and tutorials on template strings, but basically that means you can customize quite heavily what the template string actually returns. It can even not be a string, so you can return a JSON object from that if you want, or a number, or whatever. It's a completely user-defined function. So the string.raw function is a new built-in, it's backed in ECMAScript 6, and it will basically not interpret all the backslashes in the string. So when I write \n here, this results in a string with two characters, the character \, and then the character n, and not one character, which is number 10 in S, which is useful if you want to write backslashes, especially. So Scala.js has the same thing. The normal string interpolator is putting s in front, and you can also have user-defined ones. For example, raw, which is a predefined custom interpolator, which will also not escape \n. But instead of using backquotes, here it uses a custom string interpolator, which is s, which is built in. The thing is that backquotes were already used for something else in Scala, so they had no choice. Another thing is in Scala.js, it's a little bit better in the sense that you don't have to put the braces if you don't need to. So here, the braces around name, I don't have to write them. I can just use $name. It will just parse an identifier after the dollar, and it's the same. But I can still, I still have to use the braces, of course, if I want the full expression, like here. For off and for comprehensions, who has heard of the for off loop in ECMAScript 6? Oh, 3, 4. Yeah, it's a pretty nice one. So in ES5, you have to, if you want to iterate over the elements of an array, you typically use a for loop with a counter, and that's perfectly fine, right? But now if you want to iterate over something else than an array, but which is also kind of a collection, you have to use that data type's version of what iterating over it means, and it's typically not the same as this one. So depending on the collection, you'll have to use different means of iterating over it. So ECMAScript 6 introduces a uniform way of iterating over collections in the very broad sense, which is the for off loop, and which we'll call, so here on just the lm variable will in turn not contain the indices of the array, but the elements of the array. So this dechuggers more or less to this code, which is called selecting the iterator symbol property of the elements and calling it to receive an iterator. and then basically calling the next function as many times as necessary to loop through all the elements of the collection. In Scala.js, we have something like this, not quite exactly the same, but which serves to serve the same purpose, to be able to uniformly loop over all the elements of the collection. So here I'm creating a JS array with the same elements, and I'm basically using the for loop, which is a for each loop, with this symbol, and this is basically the same. This is the same as the previous example in ECMAScript 6. But this dechuggers to something slightly different. Instead of getting an iterator and looping with the next method on the iterator, it dechuggers to calling the for each method of elements and passing it a lambda, which will be called for each element. So this is basically the same thing as the for each method in on an array in JavaScript, right? And this is kind of standard in Scala collection behaving data types to have a for each method so that you can use this syntax on it. So the typical signature or simplified signature of for each is to take a function which takes an element of the type of the collection and returning anything because we don't really care about the results of the function. So just coding style thing, in Scala, we tend not to use the parentheses brace there. Instead, we just remove the parentheses and we just keep the braces, is the same. But that's what you will see if you look at Scala code written by typical Scala developers, not the previous example. Scala for loops have more syntax, so they support a bit more use cases. You can iterate over several things. You can insert guards in there. So this will iterate over all x's in elements, but then only for those where x is greater than 6, iterate from 1 to x, and then print the string interpretation with x and y. The for comprehensions in Scala also have another version, which is the for yield version, which is basically like a map. Well, it's not like a map, it is a map. Again, it's syntax sugar. It dechuggers to map. So dechuggers to calling the map function, which is basically the same as map on an array in JavaScript, with the lambda x, which is here, to the expression here. And then you can combine it all together and have a giant for comprehension with a lot of generators, guards, and yields, and you can do weird stuff with it. So never mind. The point is that you can combine it all together and everything works together in a unified way. Okay. Questions? So I'm beginning the last or next to last section, which is promises in JavaScript or futures in Scala. So you've probably, if you work in Scala, you've probably already used futures, right? No? Huh. You've been avoiding asynchronicity. But that's fine. It depends on what your use cases are. In JavaScript, though, I'm pretty sure you somehow use some sort of promises, even if it's Jacobi deferred or Q promises or promises A plus. This is all basically the same thing, and it has finally been standardized in ECMAScript 6 under a very well specified notion, which is the promise. And for Scala developers, this is not a Scala promise, it's Scala future. Scala promise is slightly different from the JavaScript promise, unfortunately. So in ECMAScript 5, you had the also well-known code like hell problem, and here it's a pretty easy version. It's just one callback, so it's still fine. If I want to add a second one, it goes over the slide, so it doesn't work. So in ECMAScript 6, we can use promises. So I can define a method Ajax that takes a URL and using string interpolation to template string, sorry, to put in the username here. And then I'm calling the then methods on the promise, which takes a lambda. And this lambda will basically be called at some point in the future when the promise is resolved. So when it has actually been completed with a value. So it implies the promise that eventually it will contain a value, but not right now. Well, maybe yes right now, but maybe not. So, and because it is JavaScript, you cannot wait for the promise to be resolved, right? Because there is no such thing as waiting in JavaScript. You always have to be asynchronous about everything. And promises are great in that because you can just call the then method and say, what do I do with this when this is completed? But I mean, this is again a callback, right? So how does it solve the callback problem? Well, the thing is you can chain them, but okay. I'll go further. Yeah, here. So you can chain them. So you can say, when the promise P is completed, I want you to do this thing, and this thing will also be something asynchronous based on the results of the first one. So it will also return a promise, but you can chain methods to calls to then with further and further callbacks that will all be completed in order when every step is completed. And that improves quite a bit on the callback help problem because you don't have all this nesting going on. You don't have to use 15 levels of nestings of your lambdas, which is basically unreadable after 3 levels. Instead, you can chain them in a more linear fashion, but it does the same thing. So let me go back to what it looks like. So I told you I can define the method Ajax. So this is how we define it. So it returns a new promise. The constructor of promise is a little bit tricky to get the first time. You have to give it a lambda that takes a resolve function and a reject function that will do some stuff, and that stuff can eventually call the resolve method or the reject method, either to complete the promise successfully or to complete it with a failure. So here I'm only showing the failure case. I should probably have an else after this if saying reject with some error message. So this is how you turn the callback version that the DOM gives you into the promise land that you can then use with things. So in Scala.js, you have basically the same thing, except that the then method is called for each, or that's the simple version of it. It has actually 3 different names depending on how you use it, but typically you don't have to worry about it, because then in JavaScript, it contemplates a little bit too much of things that you cannot write proper types for. It's just not possible. It was actually argued when they defined the promise API whether or not to include an alternative to then, which is called chain in Chrome, and which is typeable, but eventually they decided not to. Which is a pity, but at least we have promises, which is better than nothing. So in Scala.js, you have 3 of them. You have for each, map, and flat map. The simple one is for each, which so again, that is it's the one that you call at the end, when it's the last thing you do, because the result of for each is never used. So this is what you do if you don't have anything to do further. So you basically maybe update the DOM or something else that is not asynchronous anymore. The reason we use for each and not then or something or some other is that we can use for comprehensions to write this. So because the for comprehension desuggers into calling for each, you can use for comprehension to write in a slightly more direct style, something which is actually asynchronous. So this body here is not immediately called in a synchronous way because it is just calling the for each method on what is called the future in Scala, and which will eventually be called, but not right now. In that sense, the for each version of approaching iterating over a collection is slightly more powerful than the iterator approach, because the iterator approach never allows you to do something asynchronously. So there is no way you can write an iterable returning an iterator that will behave in asynchronous fashion, because the way the for is deshuggered is inherently synchronous. So the for each approach is slightly more powerful in that sense. It's it shows much better if we go. Oh, so this is implementation. So here I create a Scala promise, which is the underlying implementation of a future. So in JavaScript, I create a promise with a function that will complete the promise, basically. In Scala.js, I create a promise, and then I can write my code that will complete the promise or not. It's just a matter of taste, basically. But eventually, you return the future of the promise that doesn't expose the success and failure completions. It only exposes you the for each, and so the observed behavior. So again, back to the composing the promises in ECMAScript 6 and how it. So in Scala.js, you can use the same. And here you see that I transformed two calls of then into two different calls in Scala.js. I use flat map and for each. I won't go into too much detail into why, because anyway, I can use a complete generalized for comprehension of it. And I can just use several arrows over my chain calls, and this way I can use the article ID that I receive asynchronously from this Ajax call into this call, and eventually I also receive this one in an asynchronous fashion, and then I can use it here. So in Scala.js, you typically compose futures this way instead of using lambdas, which improves a little bit on the chaining of then methods. You can do even better. There is a library, which is Scala Async, which was not developed for Scala.js particularly, but developed for Scala in general, which allows you to write the previous code in an even more sequential style, but it's still asynchronous in effect. I just use an async block, and inside an async block, I can await for futures. And this looks like a synchronous wait for the result of the future, but it's not. It will take the rest of the block, turn that into a lambda, put it in the flat map method, and do so for all the calls. And this improves, I think, quite a lot on the chaining of promises futures. So it's so good that even ECMAScript 7 is going to have this. So that's a long way off. So ECMAScript 7 has async functions, which look a lot like this, with async and await, except that the position where you put async must be at the function level. So you cannot create a block inside the function that is async. You have to put it on the entire function. But it doesn't really matter, because you can also always create an anonymous function inside. But it's just so ECMAScript 7 is going to have this just in 15 years. Last function. Yep.
Because the futures are eager, so are they linked or? I mean, so for instance, for example, in JavaScript, they are eager, so anytime you call a method that is turning a promise, it's already happening. So it doesn't matter if you set it over or not, the method or not. But in the strategy, it's when you're calling a feature, you have to call the for each or convention.
No, so typically futures are eager. If you try very hard, you can make them lazy, but this is not their first purpose. They're fundamentally eager in the first place. Yeah, just like promises in JavaScript.
Is that also in Scala?
Yes. Except that in Scala, the JVM creating a future comes up the thread and runs the computation that you give it in the thread. In JavaScript, we don't have threads, so it all depends on how you complete the promise in the first place. So it's all up to you to decide how it goes. If you don't decide anything, the default is to set timeout 0, basically, for the block of code. So it runs after the next event loop. But typically, in the first place, you use futures, well, promises futures, because you use a fundamentally asynchronous I/O stuff, or so that you complete the promise manually. So it completes when the underlying operation completes.
Could you use Scala with Scala.js?
You could. At some point, you will be able to. It is possible to implement the actor model. I did it as a proof of concept on Scala.js. My implementation was very proof of concept, and I would really not recommend for any kind of real usage. But now there is a company which is actually developing an open source extension to this prototype, which is based much more closely to the original Akka code, but which runs on Scala.js. So the answer is yes, or soon. You can do it, yeah. And it's even possible to upload some of the actors to web workers, or to have actors communicate with through JVM actors on the back end, if you wanted to, in a transparent fashion, mostly. Okay, do we have time for this last bit? Yeah. So, last ES6 and Scala.js I want to talk about is destructuring. So in ES5, if you want some parts of an array or of an object, you would first assign the array or the object to a variable and then select the fields. Sometimes this is not the most readable way of doing it, and ECMAScript 6 adds destructuring to the syntax, which allows you to put complex looking expressions on the left, and it will assign things in corresponding positions. So here the 2 is lost because there is nothing here, but the 3 is assigned to B. And you can do the same thing with objects. So here, this up is the name of a field, and this up is a new binding. It's a new variable, or a new constant in this case. And in Scala.js, you have mostly the same thing. So it's called unapplying in Scala.js, but it's basically the same thing. So but it's the typed version. So you you write typically the name of the type on the left and on the right, and but you get the same thing. So here 1 would go to A, 3 would go to B, and we use an explicit underscore to say I don't care in this place. And we can also do it for nested stuff, just like ECMAScript 6. So in Scala.js, it goes a bit further in the sense that you can also do what we call pattern matching on this, which is basically selective destructuring. So it tries to destructure the value returned by getAST node here. It tries to destructure it with this shape. If that succeeds, then it will do the block of code here. But if that fails, it will try the next one and then the next one. And eventually, it finds that this case catches everything else, so we return the same node, for example, or something else. This is immensely useful if you write functional code based on ADTs. It's a very common pattern in typical Scala code. So I have shown a lot of features that ECMAScript 6 brings to JavaScript, and how you also have basically the equivalent or a little bit better Scala.js, or a little bit worse in the case of var-oriented arguments, and the syntax is not so nice. So I will at least say a few words about what Scala.js brings even more than ECMAScript 6. So the first thing, obviously, is static types with type inference. So you may disagree with me. I happen to like static types. They help me a lot, especially for refactoring. If you don't like them, well, you don't have to, and then you disagree with my point here. But you have to keep in mind that Scala has type inference, so that means that you write a lot less types than what you would be used to if you think about Java or languages, where you have to type all the stuff, all the intermediate variables, etc. In Scala, you typically only write the types of parameters and result type of methods, and then everything else is typically inferred by the compiler. But it's inferred; it's not dynamically typed. It will verify that this is correct. The one true thing that I think makes Scala.js apart from ECMAScript 6 or ECMAScript 7, or as it seems to be like even ECMAScript 8, is that we're immutable by default. So it doesn't matter that it is possible to write functional immutable code in JavaScript. It is possible. First, you have to use 2 more characters per local variable declaration. You have to use const instead of let. But more importantly, the data structures are immutable by default. And if you look at how languages are moving these days, it really seems that immutable is gaining traction. There is even a JavaScript library that provides data structures that are immutable. It's called immutable.js. So Scala.js is like immutable.js, but just better because the language helps you do it in an immutable fashion in the first place. You don't have to think about it to be immutable. You have to think about stuff if you want them to be mutable, on the contrary. A little bit, not too much. Another one is the collections API is much more versatile and much more powerful. And again, if you know about underscore.js, it's like underscore, but just with even more functionality. And so it's typically immutable by default. And it's all type checked. Traits. You may have heard that multiple object inheritance is a sin from C++. But it happens that you don't have to have the bad things about it to be able to profit from the good things, and that is what traits are. I won't elaborate on this today, but pattern matching, ATCs, I mentioned them earlier, and a few other features of the Scala language. And this is all about the language itself. But then you also have quite awesome libraries that in the Scala.js ecosystem and in the JavaScript ecosystem, because you can reuse all the JavaScript libraries just from your Scala code. And in addition, you have a growing ecosystem of Scala.js libraries that allow you, for example, to talk to your, typically Scala backends on the JVM in a statically typed way, and to have, for example, statically typed Ajax calls, which is with automatic serialization. So that's it. Yeah, that was about an hour. Thank you. So of course, if you have more questions, I'm happy to answer.
Is it ready for production? Is it ready?
Sorry,
Scala.js is ready for production.
Oh, is it ready for production?
Yeah.
Yes. So Scala.js users would say it's been ready for production since version 0.5, which was a bit more than a year ago. I would say it's been ready for production since version 0.6, in the sense that it is not going to change anymore. So every code that you write now is going to work the same way for the entire 1.x lifetime, which should last for years. So in that sense, it is stable, and it also works. I mean, bugs are rare, and when there are bugs, it's rarely about the compiler. I'm always happy when someone finds a compiler bug, because then I got work to do. No, seriously, it's a grown-up language. Well, it's kind of a dialect of Scala, and it's stable. It works. It lets you talk to JavaScript libraries. Semantics are well defined. They will not change, and it's also performance. I'm not talking about that, but it's bigly on par with JavaScript at the moment.
Question how is Scala? I used Scala in a big software, big company, because I worry about what you use technology to worry about the need of using technology in communication with other systems. For example, I'm worried about how Scala works with the Active Directory for security, or for example, how to communicate Scala with ES5 or SOA systems or web service in another language, for example, Java.
So are you talking about Scala JVM on the backend or the server?
Yeah, backend and communication with another enterprise software.
So I have not the slightest idea. I don't use Scala JVM except to write the compiler of Scala.js. I have no idea how it fares in for real in the backend. What I can tell you is that there are a lot of companies actually using Scala and have been using Scala on JVM for a long time, Twitter being the most prominent one. But I will refrain from going any further in this terrain, because I don't have the personal direct knowledge to answer that question. I'm afraid we have to ask Scala JVM guys who are actually using Scala on the JVM most of the time. Yep.
Scala.js has some kind of code optimization?
Yes. So the question is, for the recording, does Scala.js have good optimization? It has a lot of optimizations. It's pretty crazy about optimizations. So the thing is that the Scala.js part of the code works in a code world environment, in which basically it knows everything about the code, and you can optimize away everything as long as the optimizer is smart enough. But it's pretty smart. In particular, it will remove away most of the usage of lambdas for iterating over collections. We'll remove that away as for loops, which are while loops. It's also able to do stack allocation and constant folding, value aliasing, a lot of optimizations. So typically, the code that you write in a functional style with higher order functions in Scala.js performs on par or slightly worse than the code that you write in an imperative style with while loops in JavaScript. So it compiles away all the overhead of using Scala in a functional way to a code that is basically the same as the imperative way of writing it in JavaScript in the first place. It can even beat JavaScript a little bit on some benchmarks. Yeah.
Can you use it in the server-side with Node.js?
Yes, you can use it. You can use Scala.js with Node.js on the server. There are proof of concepts. I don't know of anyone who has actually done significant work on it. But Scala.js compiles to compliant ECMAScript 541 JavaScript code. So it works everywhere. Scala.js as such does not rely on anything that is browser related. It just relies on the spec of ECMAScript 5.1. So anything that can run ECMAScript 5 can run Scala.js code, in particular Node.js. We actually use Node.js all the time for unit tests, as well as Phantom.js and as well as Rhino.
What about debugging in the browser?
So for debugging in the browser, we do what all the languages that compile to JavaScript do, is we emit source maps. So you enable source maps in your browser, and then you basically step through your Scala.js code right from your browser. And you can, you have spec traces, you can step through. What doesn't quite work so well is inspecting the value of local variables, because the support for that in browsers is not yet good enough. It's not really our fault, it's just the browser have not implemented the relevant parts of source maps yet. But all the stack trace and stepping through, it works. It's just okay.
We said that 2 files to ECMAScript 5, right?
Yes.
Are you going to move to ECMAScript 6?
Actually, we also compile ECMAScript 6. If you change a flag somewhere, it will emit ECMAScript 6 code. Just don't do it. I mean, so that part is experimental. I wouldn't call that production ready. And what is more, well, first it works. The set of features it needs from ECMAScript 6 is only supported by V8 and Chromium, like nightly or something. Well, by Babel also, but if you compile to ECMAScript 6, only to compile with Babel to ECMAScript 5, you might as well compile to ECMAScript 5 in the first place. And the second thing, it's much slower at this moment. So VMs, even V8, which is bleeding edge, so benchmarks show that the ECMAScript 6 version is 4 to 10 times as slow as the ECMAScript 5 version. And this is the VM problem, because they have not yet optimized ECMAScript 6 as much as they could. So eventually it will be the default, and the one shooting it is as fast as possible, but not right now. We actually have another emission mode, which is ECMAScript 6 strong mode, which you may have heard of. It's the 8 thing that is like strict mode, but much stricter, and which basically rules out all the ECMAScript 5 versions of all the things I have shown so far, and only allows the ECMAScript 6 versions, in order to be able to optimize much further, or also to make it more easy to understand from a developer point of view. So we also have a target for that one, which is a little bit slower even than the ECMAScript 6 version, because we have to use static methods instead of top-level functions. But the thing is, we've been talking to the people developing strong mode, and we've been feeding back some of the stuff we learned about strong mode, and quite a few stuff have already changed in the strong mode specification because of our feedback, because we're simply the biggest producer of ECMAScript 6 strong mode code, because you can just take any Scala.js code base, compile it to strong mode, and you have a huge code base to experiment with. And all the other experiments are maybe 20 lines of code or something of strong mode, so we have a lot of feedback to give, and we do it, and we improve strong mode that way. Yeah. A use case where you would not use Scala.js? Yes, I can give you a scenario. If you want to embed a little bit of JavaScript code that would animate your button on your otherwise completely static page, you probably don't want the loads that comes with Scala.js by default. So it does that code elimination, but even so, a hello world as such is 16 kilobytes. The thing is, it doesn't grow that much afterwards. So big application goes from 100 kilobytes to a megabyte when it's minified, which is further gzipped, which is what you get typically with a big JavaScript application. But for really small application, the tax is huge. So if it's just a tiny animation script, then don't use Scala.js. But for anything that is medium to big size, yeah, there's no reason, in my opinion. Macros are allowed, yes. Compiler plugins also, if you want. Yep. So basically, the entire Scala language is supported. There are a few semantic differences that I talked about in my Scala.js talk, but typically code cross-compiles with Scala.jvm and Scala.js as long as it doesn't use libraries of the platform that are platform specific. Of course, if you use the DOM, it's clear that if your code won't compile, on Scala.jvm. If you use threads, it's clear that your code won't compile in Scala. Okay, I think that's it. Thank you again.
I don't know if you're already mentioned that. What about modules? How many modules are
modules. We compile the entire Scala.js word into one JavaScript file. Using the Scala.js. Well, so to be precise, there is a Scala.js compiler, which is like Scala C, so it compiles Scala files to individual class files and what we call SJS-IR files, which are or intermediate representation. But then we have a linker, which takes, so the SJS-IR files are published in jars to be depended on with different artifacts and such. But then at the very last stage, we have a linker that takes all the SJS-IR, optimizes it all together, and produces one JavaScript file. And the full optimized version also uses the Google Closure compiler to further optimize that JavaScript file according to JavaScript specifics. Yeah. Thanks.